आया आया ठीक है मैं डिस्प्ले पे डाल दूंगा
कैमरा के लिए इसके सामने रहना पड़ेगा कैमरा के लिए पॉइंटर है क्या पॉइंटर पॉइंटर नहीं है क्या ऑन ऑफ कहाँ से नहीं ऑन ऑफ कहाँ से होता है मैं बोले ऑन ऑफ नहीं होता है क्या
म्यूट का ऑप्शन म्यूट हो सकता है
अच्छा
ये म्यूट हो जाएगा
Hello. Good evening, friends. You all are welcome in this superannuation program of Ms. Aparajita Mukherjee. Uh, this program is in two phases. The first is that we have requested Aparajita to give a talk about her experiences. As we have started recently, that we request the person superannuating to share his or her experiences so that we also can learn about that. In fact, मैं तो अपराध रिक्वेस्ट करूंगा कि लास्ट में एक सेंटेंस हम लोग देते हैं कि अगर मुझे दोबारा IPR में मौका मिले तो मैं क्या क्या किया है, क्या क्या जो कर पाऊँ, तो ऐसा कुछ बताएंगे तो हमारे लिए अच्छा रहेगा। जो यंग जनरेशन है इनको पहले से एक ज्ञान मिल जाएगा कि भाई कैसे स्टार्ट करनी है, क्योंकि जो सच्चे हम लोगों ने खाए हैं एटलीस्ट आपको ना खाएं तो अच्छा है। तो मैं ज्यादा वक्त ना लेते हुए अपराध को इन्वाइट करूंगा कि अपनी टॉक स्टार्ट करें। धन्यवाद।
Thank you, Garching, for your intervention and the difficult question you have put from the last slide. I'll try to answer. So I will start from here. So this is basically I have so many slides, maybe around more than 80. So I will try to be very precise. And maybe if you have some kind of queries, I will come back at the end. Otherwise, I will highlight only the important points. So I started actually I joined IPR in August 1991 as a research scholar. And after completion of 1 year of coursework, just 1 minute, how I can actually, pointer is not there. Pointer is not there. Mouse भी नहीं, mouse है. Okay. So after completion of 1 year of coursework, then I have started working in beta, especially for production of plasma using RF waves. And right. Yes. Okay. Thank you. So the aim was basically to excite the Helican wave is a RF of around 8 megahertz and power was around 1 kilowatt, and characterization of the plasma and study of low frequency instabilities. And especially actually during that time, I was mainly working on finding the density profile, then temperature, T and Ti, and also I have checked for the different radial profiles of the wave magnetic field. And effect of periodicity was also observed during that time and initiated theoretical calculation to study this in detail. And other major observations are written over here. I am not going one by one. Then sometime in 1995, that is in, I think in September, I joined IPR as staff, especially for SST-1 project. But in parallelly also, I worked for the Aditya ICRH system. I was mainly responsible for design and development of launcher, that's the antenna, using BRAC and SWAP code. And then also I was responsible for design and development and installation of vacuum transmission line, we call it interface, and also having some kind of matching system, which is consist of 2 stop tuners and variable and fixed phase shifters. And during this time, I was also responsible for the operation of ICRH system with Aditya. So during that time, we did some experiments, especially considering off-axis deposition and on-axis deposition, and especially the heating scheme was second harmonic heating. Frequencies were varied, sometimes 24 megahertz, sometimes 29 megahertz. Magnetic field was also varied, and maximum power we coupled around 110 kilowatt. Pulse length was varied from 20 millisecond to 40 millisecond of the this is a flat top of the discharge, and we could match maximum 75% of the power. This is the coupling basically. And from VSWR pattern, we calculated RC. This is the real part of the impedance in vacuum as well as in plasma conditions. And from there, we calculated what is the antenna plasma coupling efficiency, and we got up to 74%. Then this basically that different discharge. We actually pumped our RF power in sometime in pulse mode, sometime in the single pulse, and then measured different conditions like in radiation, then some kind of NST, and also the fluctuations of the amplitude and time period for the sawtooth oscillation, and monitored and analyzed. So as I already explained that from 95 September, I joined SST-1 project, and I was initially worked on the feasibility studies and finalizations of the operational regime for SST-1 ICRH system, and I prepared the first engineering report. I was mainly responsible for antenna design and water-cooled vacuum transmission line peripherals, and also for the age diagnostics. As you know that the ICRH system for SST-1 is a long transmission line of 9-inch line starting from RF generator room, and then there is a hybrid coupler which I will explain later. This is basically to split the power for the 2 antenna arms, and then after that there is a matching system for each arm, and then there is a T junction over here, you cannot see from here, and this is going for the 2 antenna straps. So there are total 4 antenna straps in 2 antenna boxes, diametrically opposite ports. So the antenna was designed for 2 different modes of operation. One is a 00 phase and 05. 00 phase is monopole, and this is the dipole configuration. And this time also used BRAC and SWAP code just like Aditya antenna. And equal loading was considered for monopole and dipole configuration. This is one of the just example just to show that K perpendicular square versus minor radius is a dispersion relation, and for different heating scheme, this is ion hybrid resonance heating, and this is second harmonic heating for hydrogen plasma. Of course, these both are for calculated for the 3 Tesla operation, and you can see from here this is the imaginary part of K perpendicular square, which shows that this dumping of power was expected at the center of the plasma. Now, water-cooled antenna, this was designed for 500 kilowatt capability. I was involved in procurement, then stage-wise inspection, FAT, SAT, and get ready for integration of with SST-1. Of course, after my actually completion of my work in SST-1, when I basically shifted to ITER-India, that time our colleagues who actually installed this in the SST-1 machine. This was also tested for the low power operation using PNA. RF radial profiles in front of the antenna was measured and found as per the requirement. For the vacuum transmission line, I was involved in testing and also the stage-wise inspection for all the parts. Still, I remember that there was almost 126 number of components. Myself, Siju, and Dharmendra Rathi, we spent completely 126 nights and day, 24 hours operation to complete the UHV testing. And it was really successful, and we spent together is a really quality time to complete this task. Thanks, Rathi and Siju. Then we actually assembled all the transmission line part. This is vacuum transmission part, and then we tested for the UHV up to 10 to the minus 4 torque and kept ready for integration with SST-1. Each interface is capable of handling around 350 kilowatt of power. For 3dB hybrid coupler, actually, I was involved in the procurement of 3dB coupler. This is required to basically split the power for the two antenna arms. And this was basically procured and then tested fully at our facility as well as at the factory site. In the factory side, this is a photograph where I tested for hydro and air pressure test as per the requirement. And sorry, I missed one point that for the entire frequency band, we asked for the 4 different modular setup, which is like 20 to 25, another one is 45.6, third one for 65 to 75, and the fourth one for 91.2 megahertz modular setup. So basically for the inner conductor, you have to change, but the outer conductor is almost same. This is one of the example of low power test considering match condition as well as mismatch condition, and we got all required our response basically from open or both short. One is open, another one short, and then we considered that this is perfect for our splitting in our SST-1 transmission system. I was also involved in checking of the performance of the mapping system on various loads. In fact, for SST-1, we consider 3 different kinds of matching system. One is in seconds, this is basically offline, and these 2 are for the online matching system. I was also involved for the wideband coaxial DC brake prototyping. This is required mainly for the DC isolation between main machine and for the transmission line, because you know that there are different kind of say groundings are there, and this DC brake has DC isolation for the inner as well as for the outer conductor. This was prototype mainly for the Aditya system. It was tested up to 65 kilowatt at 24 megahertz successfully. Based on this outcome, we designed for 4 different coaxial DC brake for SST-1, and this is the just a photograph of 191.2 megahertz DC brake. But it was never tested for high power. So now in the next step, that is during the ideation of India's entry to ITER project, I took active part in preparation of the input documents for ITER. This is basically before negotiation of in-kind package sharing between different ITER partners. I also involved in the preparation of required document for our internal discussion related to ICH system and participated in lab visit presentation. Now, next I started working on ITER project since 2006. This is of course aerial view, not for 2006, this is the present aerial view of ITER site. So this slide is just for the completeness. As you know that there are 7 partners, and UE is taking the most large sharing, and all other 6 countries are taking 9.09% sharing. Each component of the machine will be delivered either by a single partner or more than 1 partner. There are mainly 2 different kinds of in-kind basically packages. One is build to print, another is function specification. The one I will describe is under function specification, where IO has specified for the all functional requirements and boundaries, and INDA is responsible for design development then up to the demonstration of the system. So there are total 9 packages, which is basically India is responsible to deliver for the ITER project. I will mainly concentrate on these 3 numbers, that is RF sources, which will be required for plasma heating, sawtooth control, and wall conditioning. So ITER required around 20 megawatt of RF power to a variety of plasma, and the frequency range is basically 40 to 55 megahertz. It's the building. In the building, there will be RF sources, total 8 plus 1, and then power supplies will be in the same building. There's a long transmission line, main matching system, pre-matching system, and then there are 2 antennas. This is the package I am considering sometime in 2016 baseline. I will consider that next, actually, whatever is the 2024 baseline, that we will discuss later. There are total 5 packages, and INDA is responsible for RF sources as well as for high voltage power supply, but of course there is a sharing. Some part will be done by IO, some part will be done by INDA. So, during preparatory activities, that is before PA signature, I was involved in 2 different main task elements. One is that considering that 8 sources to deliver 20 megawatt, another was 12 sources to deliver 20 megawatt. We compared basically in terms of technical difficulty, relative cost, and reliability, and then we found that the 8 sources to deliver 20 megawatt is always preferable. And second task was done that based on this first task, that what will be the number of components, then basically the bill of material we actually find out, and then also the specification. And completion of both these tasks, actually, this gives resulted in a successful conclusion of the ITER design review, CDR, that is they call conceptual design review. During this time, we observed these inconsistencies in between basically RF source package and high voltage power supply package. This we analyzed, and then we basically provided all the inputs to IO for raising DCR undertaking. In fact, what has happened that they consider 9 number of RF sources, and high voltage power supply was only 8, but it was actually required 18. So there is a huge jump from high voltage power supply requirement. So during PA signature, you can see some of the photographs over here. Now work continued till completion of management specification, technical specification, and main text. And then we proceed for basically internal as well as external review process. Another round of discussion held between IO and IENDA, and finally we got approval from EBs, and PA was signed on 5th of February 2010. So we have total commitment of 9 number of RF sources, and scope includes basically starting from design up to the commissioning and site acceptance of all the 9 sources. The power handling capability of each source should have 2.5 megawatt at VSW2, that means 11% power regulation in this frequency range. And using the same hardware, one has to show the 3 megawatt at VSW 1.5, this is 4% power regulation in this frequency range, with other stringent requirements. As there is no unique amplifier chain to basically able to meet the output power specification, so therefore ITER-India proposed 2 chains of amplifier and 1 combiner at the end to get this 2.5 megawatt or 3 megawatt of power. So this kind of RF source is unique in terms of its stringent specification. If we consider even the technical challenges, even for the one single chain of amplifiers is also challenging when we consider combined high power and high VSWR. Then we have to consider the CW aspect. We have to consider bandwidth, plus minus 1 megahertz at 1 dB point. Then there will be operational problems, unwanted oscillation, and mode generation. So there are n number of basically technical challenges we identified. And under design complexity, risk was registered. Basically, there is a lack of operational database, and as a part of mitigation, it was that one has to go for R&D before prototyping. In parallel, actually, we are asked to assess the performance of RF source at other fusion labs. So as a part of mitigation strategy, we took part in the experimental campaign in NIFS, that is in LHD, Large Helical Device Facility. There is one contract which was placed by IO to NIFS. And when we actually participated in this test campaign, we found that there is some issue related to their ion pump current. And in fact, there is a interlock between the ion pump current and the main RF generator, and there are several trips. Then we found that there is some kind of problem with basically shielding. Once it was shielded, and you can say there is a with shielding that current level goes down. And there is another problem. Actually, we have observed that there is a relation between ISG, that is the screen current, with ion pump current. This should not be the case in principle. That means there was some kind of shielding problem was still there. Further, we try to actually expand the plasma length, RF power length. Then we observe that around say 70 to 80 seconds, there is a sudden dip in the power level. And also we found some kind of problem when we consider from say 0.1 dB changes, 13.6 to 13.7 dB changes in the input line, we found there is a sudden increase in the power level. So obviously there was some kind of issue was there in their system, and we could not extend our pulse beyond 50 seconds at 1 megawatt level, which was different than what was the contract obligation, and therefore the contract was terminated, and we could not complete the contract properly. So this is showing basically the main basically that team were involved in this test campaign. So we have what we actually learned from this collaboration, that we learned that this LSD amplifier was not compatible with the ITER requirement. Shielding is one of the most important criteria, and for any reliable operation, we should actually analyze the failure and corresponding corrective action properly. Otherwise, we will not be able to get our targeted result. An interlock must be implemented to avoid the damage in the system. Next, during this period, 29th March to 2nd April, I think this is a 1 week only trip to test start. And during that time, they were changing from one frequency to another frequency by their supplier, that is CEC, Continental Electronics Corporation. And they basically claimed that they already got all these frequencies of operation at around 2 megawatt level for 300 seconds. And especially CEC claimed that the same generator can be basically applied for the ITER operation. But when we visited over there, we have seen that there are several different gaps between the requirement of ITER and the system at their site. First of all, that this was not fully automated. Whenever they are changing from 30 to 60 megahertz, they are changing their basically cavity 4 times. So you cannot actually start from 30 megahertz to 60 megahertz without opening HPA3. And also the height of the cavity was more than 5 meters, which is basically different than ITER requirement. And overall bandwidth was within 300 kilohertz, where for ITER it's required plus minus 1 megahertz. So that means there's a clear different kind of design was there. And we could see 600 kilowatt at 30.7 megahertz for 18 seconds. Of course, this was very short duration our visit, so they could not show us 1 or 1.5 megawatt during that time. So what we have learned from this K-star visit, that this K-star amplifier is not compatible with the ITER requirement, therefore new design effort is required. And after basically a detailed discussion with their senior people as well as the head of ICRH system, we came to know that there's a several basically conflict with CEC, and he suggested me few things. Out of that, actually, I bulleted 2 points. These were very important, and in fact, these were actually part of our next contract with CEC as well as Thales. I will explain to that later. So one part he said that always we should actually sort out all the failure scenarios, and we should find out who will be the responsibility for that particular failure, so that there should be failure scenarios explained properly in the contract, as well as the responsibility matrix, to avoid any kind of future conflict. And second point, he said that since there will be some system or subsystems will be supplied by ITER-India, so there should be verification and acceptance of ITER-India's all systems and subsystems by the supplier before integration with the cavities. So, and he said that only after acceptance of the performance, it will be responsibility of the supplier to demonstrate the full performance. And we discussed this part very widely during our contract preparation with Thales as well as CC, and took considerable time because it was very difficult to basically, agree with them that they will take the responsibility. I'll come later. So another collaboration we had with IPP Garching. In fact, this agreement was signed sometime in 2009, and there is amendment till 2013, but we completed our campaign by 2012, before that last basically amendment date. So if you see that what was the task, basically they have total 6 generators. Out of 6, 2 are actually went bad because of their aging effect, and also non-availability of particular this tube by ABB electrode. So they wanted to change this tetrode with IMAP tetrode, okay, and they wanted to have a minimum modification in their mechanical as well as in the electrical system. Then we discussed with Professor Kao and others, and especially Shishir was also there, and everyone was supported to basically start this kind of collaboration. And we said that okay, we'll be able to change this one, but there should be some kind of responsibility matrix, and we cannot take the full responsibility of output of the system, because they should own also the responsibility. So there was 2 campaigns. One was sometime in 2010, and next one is 2012. So first, actually, we dismantled 6-number transmitter, and then we measured all the dimension. And ITER-India personnel were involved in engineering drawing preparation for the tube socket, then RF simulation, and suggested modification in the existing power supplies. These modifications and suggestions were reviewed by GA as well as General Electrics as well as the IPP experts. But fabrication of all the tube socket components, procurement of power supply was under IPP's responsibility. So if you see that whatever the mechanical changeover suggested by ITER-India and ITER-India, that is basically, you can see there is the anode flange, this is the SG flange, this is spring grid, then this is a control grid, and last is the filament. So we suggested that there are different kind of adaptation is required to put in the socket of earlier tube. This we discussed with IMAP tube on suggested modification, because we are replacing their tube which is attached directly with their tube. So these flanges we removed and we put different flanges. Check the voltage standing capability, and also simulation was done for the input circuit. Some of the changes we suggested for the electrical system, we suggested some modification in the filament, screen kit was sent. We suggested for a different control grid power supply. Also, we suggested to have ion pump power supply. So based on our design, they have fabricated different parts. Then we actually asked for one dummy tube. First, we did all this exercise with the dummy tube. I mean that fitting of all the mechanical parts, then also basically checking, putting and inside this tube socket, just to check that compatibility issue. Then we actually go with a new tube, and then we conducted the hot pot test. Then ferrite tiles, we put all the ferrite tiles, get it ready, and then put inside the socket. Now, before actually powering the system, we checked for all the power supplies, then all interlocks, control. Stage-wise, we ramped up the power and finally powered the entire system. Now, this generator was down due to technical reasons since last 10 years during that time, and therefore a considerable effort was made to make the system ready. Many failures occurred, but because of IPP's spare strategy, we recovered in a very short time scale. After this campaign, we found that there is some issue with the driver stage power supply. We asked them to change the driver power supply and also the driver tube. And then we went to the next campaign in 2012. and we could achieve up to 1.5 megawatt for 110 milliseconds, and in some of the cases higher, lower power but longer pulses. But we have seen that there is some kind of problem in the driver stage amplifier. There is several trips, and then due to high current, there is basically burnout of the sliding contract, and we identify there's a limitation because of the power level. But in this collaboration, actually, we have learned many things, especially our group members exposed to different areas related to megawatt level power, which was very much beneficial for the ITER application. And we learned how to tune different amplifiers and bring the system up to the high power level. So it was a very fruitful collaboration with IPP Garching. So we understood there is a significant gap between the demonstrated capability and the ITER need, and therefore we launched our R&D program, that is the tube qualification phase, using single chain experimentation, using diac tetrode as well as diacrode in this frequency range for 2000 or 3600 seconds for 1.5 megawatt and with PSW is to 1. So the execution plan was for the first is the R&D, especially for this we actually identified the final stage tube and critical component and also tackling different interfaces. And after that in the phase 2, as a prototype, it's a 2-chain amplifier plus combiner. That means in this stage, only the uncertainty is the stability of the combiner system during mismatch condition, and bulk production is the just repetition of prototype. So in this R&D activity, we actually signed contract with 2 different suppliers. This is, I think it's with CC, and this is a photograph from TD during the contract signature. Here, if you see that what is the, we are actually purchasing from them, this is the HPA2 and this is the HPA3, the driver stage and final stage amplifier, and rest of the system was designed and developed by ITER-India, and based on the ITER specification validated its design. Then we started developing our ITER-India lab for all the facilities. There are 2 different kind of things we are considered. One is the auxiliaries and services like cooling, then earthing, bringing bringing that PPN, SST-1, everything. And another way to bring different systems. It was a huge effort, and in this effort, everyone in our group contributed. First, we got SSPA in our lab, and then followed by dummy load, and then all others basically subsystem we brought, and then we tested in situ, and then kept ready for integration with 2 different kinds of amplifiers. So this is showing that high power test rig where we tested our dummy load as well as mismatch transmission line for our high power amplifiers. So after the assembling of HPA2 and HPA3 with all transmission line, dummy load, we started basically commissioning. And before powering of the system, we did first the tuning within 180 seconds. This is between this frequency range. Then we check for the plus minus 1 megahertz bandwidth. Again, this is for the entire frequency band. And then we check for the higher order mode test. After that, we powered up to HPA2, that is up to driver stage, around 130 kilowatt, and checked all the harmonic level. Then we powered the last stage, that is the combined change, SSPA, HPA2 and HPA3, and we got 1.5 megawatt for 2000 second operation. It's a very clean signal, and also we checked for the bandwidth. You can see that the red one is for the HPA2, the green one for the HPA3, and this is the combined blue one. And this is within below plus minus 1 megahertz. This is 1 dB. You can see it is a 0.3, around 0.3, and this is also okay. This is plus minus, even not plus. It's in one side it is -2. This is a very good bandwidth at 45 megahertz. Of course, for other frequencies also we have checked for the bandwidth. Then we tested for the long pulse. This is the 1 hour pulse, 3600 seconds at 36 megahertz. This is basically design capability test, and it is passed successfully. This was a very difficult task. This was actually for checking the VSW condition. That means even with 11% power reflection, one should push the constant power of 1.5 megawatt. So during this time, we changed the bias of HPA3. You can see there are different biasing point, and of course we biased offline, and then we started operation. And you can say that even with VSWR condition, always we kept the power at 1.5 megawatt. So that means even with the LME plasma, one will be able to pump the power as per the requirement. Then we did 5 successive pulses with 25% duty cycle for 2000 second operation. So this table shows the demonstrated capability. In fact, for all the our R&D specification was basically checked and demonstrated by this diode-based system. I'm not going to do that detail of tetrode-based system. Similarly, actually, we assembled, we tested system like diode-based system. We got different power level, but you can check, you can see that beyond 55 megahertz we could not go because of higher anode impedance. And for 36 megahertz, we could go up to 1.7 megawatt. For VSWR condition, we checked again for the 55 megahertz at VSWR2 at 1.5 megawatt. Again, we could not go beyond 55 megahertz. So there are two problems with this tetrode-based system. One is the bandwidth. We could not achieve plus minus 1 megahertz. We could go up to 0.8 plus minus 0.8 megahertz. And for all the frequencies, we could go up to 55 megahertz. Hyper combine is another important our basically development. Here we design and develop megawatt level combiner and test it for as a splitter. This was tested up to 1.5 megawatt, and then it was tested for also voltage handling capability, and this was tested up to 4.5 megawatt corresponding to 21.4 kV voltage stamping capability. During this time, we have actually checked for different components, and we also developed different components like switches, then elbows, then straight section, bellows, directional couplers. This is the auxiliary power supply. This is a mismatch transmission line. This is SSP 10 kilowatt, and this is 1 megawatt download. Okay. Then I joined ITER organization in March 22, and I was actually section leader for IC system. So here actually I did technical work as well as the managerial work, but I cannot tell all the basically bulleted points. Mainly I was concentrating on antenna design and development package for this antenna package, and also the some kind of transmission line, port cell integration, and also conducted high voltage power supply FDR and high voltage power supply FDR. So in nutshell, I can say that there are main achievement that for completion of IND high voltage power supply FDR and high voltage power supply FDR and tender completion of tender process for antenna. Antenna is supposed to sign by next week, probably. We have cleared the MAC approval also. For managerial contribution, I prepared a cost book, cost sheet for this baseline 24 and presented in different review meetings. Then I was also involved in budget preparation, schedule, etc., and then prepared for the different documents for stack, MAC, etc. Okay. Now, as you know that there are different basically approach in ITER. The new baseline, that is, we call it the 2024 baseline. This has changed armored material from beryllium to tungsten. So there is some kind of challenging situation with our system because of tungsten environment, and because in some of the machine it has seen that with tungsten there is a lot of impurity generation. So sometimes it happened that there was some decision that there will be no ICRH system, and after that we did some kind of calculation with the help from IPP Garching and also from CA, just checking the impurity generation, and we have seen that for particular phasing, one can achieve the proper dumping of the power. And modeling shows that even with this constant environment, ICH power can be dumped up to 20 megawatt per antenna, and that time sputtering can be below 10% without ICRH. So this need to be demonstrated experimentally. So it is proposed to implement ICRH system in a phased manner. Initially there will be 10 megawatt, that is called SRO, that is start of research operation. Primarily it will be used for ICWC, that is wall conditioning purpose, as well as test for ICRH coupling and compatibility with the ICRH system for tungsten 1 first. If there is a proper demonstration, then there is a possibility to increase the power from 10 megawatt to 20 megawatt. So there is a phased approach, and this ICWC is requirement for the DT1. This is for the licensing purpose, and therefore now it is a very important system for the ITER. So this is the baseline for the 2016, where there are 2 antennas, 8 transmission lines, all 9 RF sources, etc. And this time, all the components over here are supposed to be located in building 15 north side. Now, under the 2024 baseline, that is in the SRO, it has been modified. So now that building 15 is now allocated to ICRH. So there is a new building, we call this building 20, where 4 number of RF sources will be there, and there will be 4 number of transmission lines. So there is a reduction in the scope. So new location, then 1 antenna instead of 2, 4 RF source is reduction from 9, 8 high voltage power supply reduction 180, transmission line there will be only 4, as you see over here. However, there will be no changes in the equatorial port 11. Equatorial 13 in the building 11. So if you see, there are 2 different of basically phasing. One is for the 10 megawatt, another for the 20 megawatt. In the first phase, there will be 4 sources, and they will be connected directly to the splitter. Here the splitter for 8 transmission line, and finally it will be connected to the antenna. In the next phase, if we go for 20 megawatt, then only the changes will be in our new building, where another 5 number of RF sources will be attached, and then auxiliary systems will be also attached with this, and then there will be transmission line and combiner will be there, and finally there will be 4 number of lines will be passing from building 20 towards the ITER machine. If you see what are the progress on the ICRH components, especially here I will describe about the antenna. Antenna is now under final design phase. FDR, the final design review is in 27. So this antenna is capable of handling around 20 megawatt of power. Therefore, in upgraded scenario, there is no need to change any antenna. And this antenna package consists of ICRF main antenna, its vessel hardware, interface transmission line, and tools. During PDR, which was done in sometime in 2020, that time we have seen that antenna performance is compliant with the physics needs, and RF design is conforming to the system requirement. Now this antenna and its peripherals will be basically finalized based on the prototype manufacturing and test. So there are few prototypes which are foreseen for ITER antenna. So first is the strap. Strap means, I can go back. These are called straps. So this the prototyping is going on the straps. Then there is prototyping we did for the double square metallic seam, and also presently I is working for quarter antenna prototype. This is basically there are total 5 phases. First 2 will be basically on the design part, and then there will be prototype in the 3rd phase, which considering that sometime in 27 we will get this prototype, and then that will be tested under RF environment, that is at the 45 kV it will be tested, and then corresponding basically changes will be done if it is required. Otherwise we will go for bulk production. So for this antenna will be tested in the high power test stand. Initially, it was basically considering that there will be test stand in CA, which is adjacent to ITER site, and but now we are considering that in the port cell test facility that is within ITER, it will be tested with full basically requirement, and then it will go for the next phase, that is for the bulk production. So tendering for prototyping is basically considering prototyping of the RF source is considering sometime in beginning of 25, and test of quarter antenna is expected sometime in 27. So there is a chance that India will take also part in this procurement of RF source, and maybe some part of the transmission line that we discussed in the last, basically before I left ITER. So there are other prototyping is also going on for the RF windows. Basically, competitive R&D program is underway. 3 suppliers are working in parallel. High power test is expected in 25, and then best supplier will be selected, and manufacturing delivery will be by 29. There are other prototyping is also in parallel. We are doing also different prototyping, that is for direct clamping, then Atlas prototyping. For this Atlas prototyping, this technical specification is completed and call for tender is underway. There are other parts with the Faraday screen, and arc detection method is also ongoing. So since the position of the building has changed, so I was also involved in layouting of the transmission line from the building, new building 20 to the building 30, penetration, and then for this all transmission line and matching system network. Then I was also involved in the layouting of ICH in gallery and ICH in the port cell, and then implementation of the ICH system. So this is the building 20, where the 4 number of RF sources will be basically installed, and once the PF coil will pass through this line, then there will be some space available for the next stage building. So first there will be 4 number of sources over here, then extension of the building will be over here, and then 5 number of sources will be installed over there. And there is a lots of discussion held between ICRH team and also the civil person regarding the size of the building, structure, and the level of the building. And now finalized, it has been finalized with that building is currently of 4 levels, one will be the basement, and then with 3 levels. These 3 levels will be for the ICRH, and the basement will be for the SSTM. And then we defined all the functional interfaces. However, physical interfaces are currently ongoing. So these are the some of the administrative and organization experience, and I was actually sometime member, sometime I was chairperson of a different committee in IPR, in ITER-India, as well as in ITER organization, and I participated in different design reviews, sometimes PDR, CDR, FDR, interim reviews, etc. So this is the end of my talk. So this is the family behind the continued development of ICRH, some of the precious moments. This when we first received our SSPA in our lab. This is the first component we received in our lab, and then this is the second component is the dummy load when we received over here. You can see everyone is very happy to get the dummy load. It's a 3 megawatt dummy load. And then this is for the MMPL system, mismatch transmission system, and this is when we first achieved 1.5 megawatt with different GSWR and different frequency level. So thank you everyone for being a part of my journey. I think it was incredible, and I enjoyed my journey, and I thank you all for your continued support. Thank you.
Thank you, Aparajita. Aparajita की टॉप से मुझे एक चीज लगी, और मेरा रिटायरमेंट अगले साल आने वाला है। तो जब बैक में बोलता था कि मैं बैठ के यार आदित्य ने 35 साल लगा दिए, कुछ किया कि नहीं किया। आज टॉप नहीं किया तो मैंने बोल दिया क्योंकि मैडम को बहुत सारे कामों में हम लोग इन्वॉल्व थे, तो पुराने काम याद आ रहे थे, तो थोड़ा कॉन्फिडेंस बढ़ा गया, ऐसा नहीं तो कुछ नहीं किया, कुछ नहीं किया। अभी आप लोग जो क्वेश्चन पूछना हो तो आप लोग पूछ सकते हैं, क्वेश्चन आंसर। Anybody can ask? आगे का प्लान।
तुम्हारा ये क्वेश्चन सिस्टम के लिए है ना पर्सनल है? ये क्लियर करो पहले।
मैडम पूछने के आपका क्वेश्चन टेक्निकल है या पर्सनल है? दोनों केस। टेक्निकल नॉन टेक्निकल दोनों प्लान क्यों बताते हैं?
अच्छा, टेक्निकल प्लान जो है, आई थिंक दैट आई मीन दैट group will continue with their basically plan. They will go for prototype and then bulk production. But as you see that in 2024 baseline, we required only 4 number of resources, not the 9. So there will be some gap in between. So I think that Trivedi will be able to tell that how he will be able to tackle. And personally, if you say that I don't have any plan at this time, but obviously I will take some break. And then I will decide on my next venture.
सर मेरा एक क्वेश्चन है, जैसे पहले हम लोगों ने प्लान किया था कि 8 सोर्स जाने हैं वहाँ पे ITER फ्रांस में, एंड दिस ICRH वाज going to play major role for BP. जहाँ पे मेरा नॉलेज है, मुझे बहुत इतना मुझे कुछ नहीं पता है। ICRH का भी जो पोर्शन है बढ़ा दिया है, एंड ICRH का पोर्शन वो कम कर दिया है। तो ICRH का जो मेन ITER में कंडीशन होने वाला, तो आई थिंक करंट प्रोफाइल कंट्रोल करने के लिए along with the heating, क्योंकि ICRH purely for heating था। कभी
In fact, ICRH और ECRH both जो है ना, this is for heating purpose only. Current drive will be done by mainly by NP. Okay.
करंट कंट्रोल नहीं, प्रोफाइल कंट्रोल जो है
नहीं, प्रोफाइल कंट्रोल उसी प्रोफाइल कंट्रोल एम है, एल कंट्रोल NTM कंट्रोल होने वाला है, न्यू क्लासिकल क्लियरिंग मोड। NTM क्लियर मतलब कंट्रोल होने वाला है, बट हीटिंग उसमें होने वाला है, नॉट करंट ड्राइव है, बोथ द केसेस।
जो है जो इसमें ICRH होने वाला तो वो ICRH में किया है।
तो अभी प्रॉब्लम ये है फॉर ICRH दे हैव सम डाउट, because the problem is that sometimes what happened that instead of fast wave, slow wave start propagating, and slow wave can dump the power at the edge. If it dumps the power at the edge, then what will happen that there will be lots of impurity will generate, because at the edge all the particles are high energetic, they will go and basically strike and sputter tungsten. When it was beryllium, the problem was less, because beryllium is low Z material, tungsten is high Z material, therefore you can dilute the plasma very quickly. So there is some kind of concern that if we go for high power for ICRH, there might be some problem to continue the discharge. So then we actually went to different experts, especially for IPP Garching and for CEA experts, and then they did 2 different calculation. Okay, one is called 0D and another called 2D. And in that simulation, they have shown that the impurity level will be maximum 10% of the background. So, for example, if background is say some 10 to the power say 20, so it will go maximum 10% of that. So that is the way actually then management agreed on that. Okay, we can proceed for 10 megawatt. In fact, Shishir and Indronil, they actually helped us a lot to bring back the system, because sometime in between it was there 2023 January. Actually, my line manager called me and asked that okay, your section will be dismantled. You will be put somewhere. They will be put somewhere. They already distributed all the manpower. Okay, so that was the situation. And then there's a very challenging situation. We are completely sidetracked, and then after lots of negotiation, lots of challenging situation, and then all these supporting documents, we came back up to 10 megawatt. Obviously, this is especially for the ICWC, but during that time, it will be checked for ICH as well.
This is timeline, 10 megawatt.
ये 10 megawatt होगा ICH के लिए heating के लिए.
अच्छा, अब क्वेश्चन ये जैसे अपना प्लान है कि we will have option for this 20 megawatt also for this ICRH, which is 10 megawatt, right? लेकिन जो antenna है, single antenna will handle, single port will handle for this 20 megawatt. 20 megawatt का उसको मतलब उसको कुछ टेस्टिंग का कुछ प्लान होगा कि it will be tested for 20 megawatt, really it will handle to this 20 megawatt.
In fact, you know that in this case, actually, we have to check in terms of voltage and current. What happened that, just give me 1 minute. So, basically, this there are total 5 phases in this contract. No? Whatever contract we, I will be going to place in the next week. 5 phases. First 2 phases is for the manufacturing details. They will go for the manufacturing details and pre-prototype. Pre-prototype means small part they will make and just change with the benzene, etc. And in the next phase, 3rd phase, they'll go for the prototype. Prototype means 1/4 of the module. So this one antenna is made of 4 different models. So one module will be basically built. And then that module will be checked for fully for this 45 kV operation. So this will give basically some kind of confidence level that we will be able to go. No. Only the voltage and current will be tested. Because in this frequency, there is no way to check that kilowatt per centimeter or megawatt per meter square. This concept is not there for this kind of antenna. This will be tested for the full power. This 45 kV is also expected for each module during the entire antenna part.
Hi. Is it made of tungsten or is it copper?
Antenna जो है ना वो that is not made of neither tungsten nor copper. ये basically होगा आपका inconel से, because inconel is very strong ना, it can withstand very high impulse. Inconel और उसका ऊपर copper coating है. Copper coating is mainly for direct purpose. Okay? Sorry.
Like conductor.
हाँ वो basically उसमें current flow होगा ना, इससे उसमें ऐसे करना है तो आपको फिर 5 years level तक करना है. Highest frequency of 5 years, so that 95, almost 99% current will be flowing.
You are testing it on real load, so you have to take into account the whole system, like the battery, vessel impedance, whole system, or you just.
Actually, there are 2 different types of operation. One will be basically you have to put this antenna in front of antenna. You have to put the water load. Water load will be like your plasma load, and then that will be tested. I mean in atmosphere. Now next test will be done for this kind of test where you have to check in the vacuum level. Then say for your high flow rate, this will be, I think that for 40 bar with the pressure for I think for 4 or 5 hours, and then this 45 kV operation has to be done to check that basically this should withstand that kind of voltage. This will be vacuum.
Experiment going on for plasma modulations with the surface of the engine.
The problem is that there is no facility where you can test this antenna.
But in other parts of Europe, like laboratories, like
yes, similar kind of experiment. AUG, that is the aspects of it. They did all this experiment. Yes, all this experiment. But this kind of dimension, this kind of configuration, will not be able to test anywhere because of the very big size. I think this way is 2 meter, this way 1.6 meter, and width-wise around 3 meters. Even small prototype, even 1/4 antenna is also very big for any kind of, any machine. We try to check actually in different machines that whether it can fit. It's very difficult.
लेवल खासकर इधर इंडिया का ICRH ट्रांसफर जो ICRH के बना था दैट इज साइज के पास
Huh?
बस के साइज के लगभग
Almost small bus.
So any more question? So if there is no more question, we will thank Aparajita for this very nice talk. And special thanks for the effort that the people have put up in bringing that ICRH back in the ITER basic. Otherwise, once it was started, ICRH is actually going out of this ITER scene. So thank you for that. So now this technical session is over. Now we'll start the superannuation program. So I'll request our staff club team. क्या आपको संदीप है क्या? In the meantime, if someone would like to share his or her experience with Aparajita, is most welcome.
मुखर्जी
मुखर्जी साहब बात
यही है
तो दूसरे क्लास
एक ही है ना
मुखर्जी साहब तो लास्ट में पूछेंगे उसको बता दें सब खत्म हो उनको कुछ आइडिया कुछ बोलना है तो तब तक क्या होता है मुझे आगे बोल सकता है
ये है ना ये
एनीबॉडी
सेकंड
कोई भी बोला था मैडम रिटायर हो गए डर क्यों रहे इनके काल पास खुल के बोल सकते हो
So actually, I would just like to say that she has been a mentor, our guide, advisor anytime. So we'll be really missing her because in technical, non-technical for everything, because like she is always available. So it was a great help. She could seek a guidance for all the matters. And I'll be really missing her. That's all I have to say. Thank you.
छोटा सा पीपीटी हम लोगों ने तैयार किया है और एक एक्सपर्ट है पीपीटी में बट आई थिंक वो बिजी है सो this is a brief summary. So Aparajita joined in 1995 and this is a message from अभी मैं ऊपर बोल रहा हूँ अरे खा लिया हाँ आ जाओ नितेश हाँ हमारे पुराने बोर्ड मेंबर हैं नितेश के साथ प्रॉब्लम ये है कि तेरे घर 5 साल में दूर चले इनको इनको तो बहुत सारे कारण में बोलने का मौका मिलेगा।
मैंने आरएफ ग्रुप में ज्वाइन किया था 99 की टीटीबी बेस से 2000 में ज्वाइन किया था। तो जिस दिन मैंने ज्वाइन किया उस दिन सभी लोग मुझे सांत्वना देने आए थे कि भाई आपका बोरा सर के ग्रुप में प्लेस हुआ। उसके बाद मुझे रूम नंबर 33 में मिला। मतलब तो क्या होता था कि मैडम थे मेरे पास में, द्विवेदी जी थे, सभी लोग जो आरएफ के थे वो 33 रूम में थे। तो बोरा सर का जब रूम आता, मतलब फोन आता था तो हम लोग समझ जाते थे। इसके बाद कोई बोरा सर के रूम से हमारे रूम में आता था तो भी हम समझ जाते थे। और ईश्वर का ऐसा है कि मतलब वो दोनों, जैसे बोरा सर से हम लोग मिलते थे, डांट खा के आते थे, तो मैडम का नेचर इतना पॉजिटिव फ्रेम ऑफ माइंड वाला था कि आप बिल्कुल कूल शांत हो जाते हो। एक बार मैं पहुंच गया बोरा सर से पास, सर मुझे फिजिक्स में कुछ समझ में नहीं आ रहा है। बोरा सर ने कहा व्हाई डोंट यू जॉइन द फिजिक्स मीटिंग। 6 महीने तक मैंने फिजिक्स मीटिंग अटेंड किया। उसके बाद एक दिन मैं से रहा नहीं गया तो मैं सर के पास गया, मैंने सर फिजिक्स समझ में आ गया, अब इंजीनियरिंग मीटिंग। तो ऐसा है कुछ। और मैं हमेशा ये मानता रहा हूँ मतलब कि मैडम की जो फ्रेम ऑफ माइंड है वो काफी अच्छी है। और अपने जितने साथी हम लोग कई बार पीएसएसआई वगैरह में एडटेक लिखते थे, कुछ भी लिखते थे, तो उस समय तो इतना नॉलेज नहीं था, मैडम को दिखा दिया करते थे। और आप देखेंगे तो मतलब आईपीआर में कुछ ही जोड़ियां ऐसी हैं जो कहते हैं कि भगवान राम मिलाई जोड़ी है, तो ये तो प्लाज्मा मिलाई हुई जोड़ी है। सर का तो मैं कहता हूँ हमेशा कि ये सर संकट मोचन है। मतलब मैंने अपनी लाइफ में भी कई बार देखा है पीएचडी के समय सर ने कई बार मुझे डूबते हुए पानी से बाहर निकाला है। और मैडम का बहुत ही अच्छा बिहेवियर है। मतलब ईश्वर इनको आगे बहुत ही अच्छी हेल्थ दे और हमेशा ऐसे ही बनाए रखे जैसे ये है। धन्यवाद।
अगला यादव तुम आ जाओ, खाना खत्म हो गया है। खाना आगे से ध्यान रखें, खाना बाद में दिया करेंगे। हाँ लाठी आ जाओ। पूरा सब सुबह कहाँ बैठे पीछे है, दूर से मैं नहीं बैठना है।
मैंने 2000 में ज्वाइन किया था और सबसे पहला मेरा जो काम था वो मैडम के साथ ही था। तो शुरू से जो मैंने सीखा उनसे कि कोई भी चीज वो पोलाइटली एकदम, कोई भी स्ट्रेस में नहीं, कोई भी काम जो है सिंपली, भाई भले बोला सर कुछ भी चिल्लाए या जो भी करे, बट हम रूम से बाहर आके हम वो डिसाइड कर लेते कि वो काम कैसे करना है अपने लेवल पे। और मैडम ने जो भी आज तक इनका जो नॉलेज है आरएफ में, फिजिक्स में, वैक्यूम में, उन्होंने हर लेवल पे हर चीज को समझाया कि इस काम को कैसे करना है। और उसी का जो आज एक ग्रुप ने, आईसीआरएच ग्रुप ने काफी प्रोग्रेस किया है। और बहुत ही जगह हमारे जो भी लोग हैं आईसीआरएच ग्रुप में, सब ने अलग से नॉलेज गेन करके बहुत से दूसरे ग्रुप में जाके भी बहुत काम किया है। तो मैडम ने अभी तक जो भी काम किया और जो सिखाया है वो बहुत ही हमने उसको एक्सेप्ट किया और उसको आगे बढ़ाया और उस काम को सीखा। और हर काम में आरएफ से लेके फिजिक्स में, मैकेनिकल, वैक्यूम, इवन हम उस डिसिप्लिन से नहीं है तो भी हमने उस काम को सीखा और हर काम को पूरा किया। और एक जाते वक्त मैं एक लाइन मैडम के बारे में कहना चाहता हूँ। आपके साथ कुछ लम्हे, कई यादें बतौर इनाम मिले, एक सफर पर निकले थे और तजुर्बे तमाम मिले। हमने आपसे बहुत सीखा है और आगे भी सीखते रहेंगे। आप हमारे रियल ट्रू मेंटर है और हमेशा याद करते रहेंगे।
एक्सपीरियंस शेयरिंग का ये सिलसिला चलता रहेगा। इन द मेन टाइम मैं सीसी साहब को रिक्वेस्ट करूंगा कि अपराजिता को बुके और सील दें स्टाफ की तरफ से। मुखर्जी साहब। अभी मैं मुखर्जी साहब को रिक्वेस्ट करूंगा कि अपना एक्सपीरियंस शेयरिंग उन्होंने एक्चुअली नाश्ता भी नहीं किया है, इसका मतलब वो कौन आए दो जिम्मेवारी है, पुलिस की जिम्मेवारी, पति की जिम्मेवारी। तो
वो उनकी चॉइस है।
तो मुझे पता था कि राज सिंह एक समय तो मुझे बुलाएंगे, और वो कब बुलाएंगे मालूम नहीं था। इस चक्कर में मैंने वो ब्रेड पकौड़ा आइसक्रीम लिया ही नहीं, उसको बोला कि मैं बाद में लेता हूँ। तो बिफोर आई स्टार्ट टेलिंग अबाउट माय एसोसिएशन विद अपराजिता, लेट मी टेल समथिंग एल्स। कि राज सिंह ने इससे पहले पूरे रितेश सुगंधी के बारे में बताया कि हर 5 साल के बाद ग्रुप चेंज करते हैं। आप लोगों को मालूम है कि नहीं, वो अब आजकल लियो डिवीजन में है, पर वो काम करते हैं जेम के लिए। तो अगला भी रेडी है। Anyway, don't take it. He is actually working on instrumentation and things about Lego project. अच्छा, so I will tell firstly that something which we do not discuss at home is anything what she showed over here. हाँ, इनफैक्ट कल रात में वो प्रिपेयर कर रही थी तो माय सन वाज इंटरेक्टिंग एंड टेलिंग ये ऐसा होना चाहिए, वैसा होना चाहिए, ऐसा बोलना चाहिए, नहीं होता, और मैं आराम से ब्रेड ऑमलेट बना रहा था। So I realized that the first thing to do is that you have to excel in something. So what to excel in? So I started excelling in cooking. And hello, that I should excel in cooking because she doesn't like cooking. So एकदम ठीक ठाक है सब कुछ, इक्विलिब्रियम में है। And ये करते करते I actually started liking cooking, and even now also I like cooking. तो घर में जाके रियलाइज की अगर आप बोलो कि मैं ये बना देता हूँ, चाहे वो चाय हो, कॉफी हो, कुछ भी हो, या ब्रेड पकौड़ा ये वो कुछ भी हो, एवरीथिंग इज इन इक्विलिब्रियम, एकदम फाइन है। एक तो अपना खुद का जो स्ट्रेस है वो भी निकल जाता है, और थोड़ा बहुत इधर उधर होता है, बट इट डजंट मैटर। So basically these slides which essentially tells her journey in the last maybe more than 30 years, and many of you may be knowing that she is actually not from Calcutta. She is from a very small town. She was born and brought up. Then Calcutta, in Ahmedabad, Ravi, last 2.5 years in ITER. So this journey actually, if you start see from outside, from a distance you see, it is not easy because I have been involved in the various DST committees and other things. We have found that we have very less number of basically the female scientists, especially in the field of technology, means within the country. And she is probably one of them who has gone to that heights. हमको लगता है कि अपना कोलीग है, ये है, वो है, but it is not easy for a person, specifically from the background in which through which one comes, to go to that height in terms of demonstration of high-end technology. Basic science look कर लेता है. So this is something which probably the system has given that opportunity, and she has put her efforts. By system I mean IPR management, decisions, taking part in ITER. Again, ITER by itself also, and in fact some of the staff of ITER who actually work, I think इनके जो senior थे, BR मैडम और बाकी डी कजारियन है, ये सब नाम जो मैंने सुना, मैंने उनसे कभी इंटरेक्ट नहीं किया। So in ITER, I found probably there may be many such people who are at the very high end of technology demonstrations. So this is something which I think the young people, especially the people who have joined in the last few years, they should take inspiration and think that they can also do such type of thing. The system will support it. So this is one thing which I thought that if I am called by Raj Singh, I will tell. बाकी वैसे सब ठीक ठाक है, and she will take a rest for maybe I don't know maybe months, days, or maybe 1-2 years, and then again she will do something. I know she will do something. हाँ, again जब मैं अभी गया था 3 वीक के लिए, मतलब before she came, and first of all driving on the other side of the road, हम लोग लेफ्ट से चलते राइट में चलते, ये वो, I found it very difficult. सिग्नल इधर है उधर है, then in France everybody follows signal, यहाँ पे कोई follow नहीं करता है ना. So वहाँ पे she was driving और मैं पीछे बैठ के मैं बोलते मैं सामने नहीं बैठूंगा। हाँ, वो भी क्या 100-120 स्पीड पे जो हम लोग कभी यहाँ पे चलाते भी नहीं है। So I think she has learned that side also, that how to drive on the other side of the road. So maybe even another opportunity comes somewhere, she will again work. But I don't know. Abhi to she told that she will take a break, so it's fine. So this is what I wanted to tell. मतलब ऐसे unplanned. Tell you. कहाँ है नर्सिंग? हाँ. Anything specific? I think Ranjan has been trying to ask questions to me for 2 minutes.
आप लोग क्वेश्चन पूछ सकते हैं मुखर्जी साहब।
Don't ask about those slides.
टेक्निकल नहीं।
Actually, the other way around. Usually, the lady in the house cooks the वो बातें बोलते हैं ना मैं चाय लेके आओ पकौड़ा लेके चाय लेके आओ पकौड़ा लेके आओ नाश्ता लेके आओ हमारा तो उल्टा मैं पहले जाके बोलते हूँ जैसे हमारा कुक कम से 7 PM तो मैं सुबह से अगर राजमा है तो सुबह पानी में डाल के रखता हूँ ये मैं कल ही किया था कल नहीं परसों हमारा घर में राजमा सुबह मुझे मालूम था राजमा अगर राजमा ले रहा है मैं अगर सिर्फ राजमा डालूंगा तो नहीं होगा तो पानी भी भर के रखता हूँ तो ठीक है अभी तो इक्विलिब्रियम में है ओके थैंक यू वेरी मच इफ आई रिमेंबर समथिंग आई विल कम ऑन
Thank you, Mukherjee sir, sharing this nice experience. And as he rightly said, वो कहते हैं ना पहले सुनते थे कि हर वर्ड के पीछे एक और कहा होता है। यहाँ पे आप कह सकते हो कि भाई हर वर्ड के पीछे एक वर्ड कहा होता है। It's really encouraging also to support a lady to reach at this stage. It's not possible without the help of the husband. Let me accept it, and we are thankful to Mukherjee also that for his great support that we have provided to our husband. अभी कुछ दिन पहले मैंने कुछ दिन 3-4 महीनों से मैंने एक चीज नोट करके शुरू की थी कि मुखर्जी साहब को टेंस लग रहा था इतना स्माइलिंग पर्सन आदमी एकदम से कैसे वो टेंस नजर आने लगे बहुत रीजन कोशिश करा सोचने का ये काम हो सकता है ये काम हो सकता है मुझको समझ नहीं आया लेकिन संदीप के पास आया 2 महीने पहले बोला सर वो हमारे तरह में बेकार हो रही है और वो फ्रांस से आ रही अरे टेंस क्यों लगे देखो वाइफ इतनी अच्छी वाइफ आपका वाइफ और फिर वो कहते ना किसी कोई शेर पिंजरे में हो आप तो 2-2.5 साल के बाद छोड़ दो सोलो पिंजरे में आएगा कैसा लगे आदमी मुखर्जी साहब आपने 2-2.5 साल 2-2.5 दिन भी नहीं मिलता है इनसे आगे मतलब जैनू ने बात बताता तो 4 दिन की जब कॉन्फ्रेंस होती है ना कहते हैं हम लोग अंजू को बोलता हूँ कि कॉन्फ्रेंस में जाना है 4 दिन में जाना है और मैं साथ चलती हूँ ना देखो वो काम नहीं किया मेरे को बोला मेरा ऑफिशियल काम है जाना है बोला तो कोई बात नहीं मतलब मैं ऑफिस काम है बोल रहा हूँ ऑफिस वहाँ बिजी रहूँगा तो क्या मार्केट में बिजी रहूँगा करता रहता है तो नाउ आई रिक्वेस्ट आओ यार कोई बोलो हमारे बारे में कैसे बात है बातें आप तो दूसरी प्लेट खा रहे थे। मैं मुझे देखा था खा रहे तो मुझे यहाँ पे गूगल मीट में दिखाई देता है।
मैंने IPR ज्वाइन किया 2008 में, तब से मैं मैडम के अंडर में ही काम किया पहले। फिर उसके बाद त्रिवेदी सर, अभी रजनी सर के साथ हूँ। पर मैडम के साथ जर्नी जो था बहुत अच्छा था। मैं प्राइवेट से यहाँ पे ज्वाइन किया था, बहुत सारी चीजें सीखी यहाँ पे, इवन मतलब टेक्निकल भी, और मैडम का गाइडेंस इट्स वेरी नाइस। टेक्निकल चीजों में कहीं भी कुछ भी अटकते हैं तो शी हैज ऑल आंसर कि कैसे इसमें से निकलना है, छोटी छोटी चीजें। और नॉन टेक्निकल में भी कहीं कुछ अटका तो मैडम, जैसे सुमन मैडम ने बताया, एवरी एस्पेक्ट में शी गिव अ वेरी गुड गाइडेंस टू अस। आप अभी रिटायर हो रहे हो पर लग नहीं रहा है। तो बेस्ट ऑफ लक फॉर फ्यूचर। और आपकी कमी तो हम सबको खलेगी ही, तो और कुछ ज्यादा ना कहते हुए बेस्ट ऑफ लक और थैंक यू।
Thank you, Deepak. Now I request Yuvraj, बोलना तो पड़ेगा भाई।
वैसे ज्वाइनिंग तो मेरी अपराजिता से पहले की है, लेकिन उस ज्वाइनिंग में हमने और अपराजिता के आने के तक नॉर्थ पोल और साउथ पोल दोनों के दर्शन किए हैं। पहले जो बोरा साहब के जख्म में होता था, जो सुबह सुबह तांडव होता था, एक आदमी के साथ नहीं, एक मेंबर के साथ में नहीं, बारी बारी से, तो वो जो तांडव होता था वो भी देखा। और बोरा जैसे बॉस को भी हम लोगों ने फेस किया, ठीक है। उसके बाद में जब ज्वाइन हुए ईटर में तो अपराजिता आई, ऐसा तो मैंने कभी नहीं देखा। यह हमें कभी बॉस लगी ही नहीं। एक बहुत ही काम, हर चीज को समझने वाली, किसी भी प्रॉब्लम में सपोर्ट करने वाली, ऐसा मैंने नहीं देखा। अब इनके जानने के बाद में थोड़ा तकलीफ तो होगी, लेकिन ये झेला जाएगा। ये भी समय है, उसको सिखा देता है ना। तो कुल मिला के हमारा तो अपराजिता के साथ में बहुत अच्छा एक्सपीरियंस रहा है। नॉट ओनली ऑफिशियल, हम लोग फैमिली लेवल पे भी अच्छे संबंध में, उनके साथ में अच्छे संबंध है। और रिटायरमेंट के बाद में मैं यही कहूँगा कि जहाँ भी रहो, जैसे भी रहो, खुश रहो, एंजॉय करो लाइफ को। और जो चीजें बाकी रह गई हों कि भाई अभी ये मेरी तमन्ना है करने की, कोशिश करो, शायद भगवान हेल्प करेगा उसमें, वो भी पूरा हो, है ना। ओके, तो ठीक है, हैप्पी रिटायरमेंट। मिलते रहेंगे, जरूरत पड़े तो हम आपको इनवाइट करते रहेंगे एज ए एक्सपर्ट। हाँ, इसमें क्या दिक्कत भाई, बहुत अच्छा उनका नेचर है आपको का। और मैंने पहले भी बोला, मैंने देखा है। तो थैंक यू एंड ऑल द बेस्ट।
थैंक यू रघुराज। रघुराज को बोलते हुए देख के मुझे लग रहा था कि उसके दिल में सही में एक दुख की भावना है। तो हमारे उनको जो देख के लग रहा था कि जैसे हमारा कोई बहुत प्यारा हमारे से जुड़ता है, तो जो तो दुख जो होता है वो अंदर से पता चलता है, अंदर शब्दों से पता चलता है। आप थैंक यू। मैं भी प्रमोद को इनवाइट करूंगा। हम लोगों ने काफी बहुत आपके साथ टाइम बिताया है, तो मैं आज का प्रमोद सुनील हम 3-4 लोग थे जो लाइन ऑफ फायर पहले खड़े रहते थे।
हम दोनों का सफर जो है वो 91 पर ऑलमोस्ट इट गोज टुगेदर। वी जॉइंड इन 91 एज अ रिसर्च स्कॉलर। हमने अपना कोर्स वर्क साथ में किया। देन वी फॉर्चुनेटली अनफॉर्चुनेटली वी जॉइंड द सेम गुरुजी। बोथ ऑफ अस बिकेम एक्सपेरिमेंटलिस्ट आफ्टर दैट। बीटा पे काम किया एंड ऑल जो है, बट बिफोर दैट आई थिंक सो हमारे प्रोफेशनल रिलेशंस तो बाद में हुए हैं। जब हम रिसर्च स्कॉलर हॉस्टल की लाइफ में जो लीड कर रहे थे, आई थिंक सो द पर्सनल अटैचमेंट जो है वो हमारा तब से शुरू हुआ था एंड टिल डेट इट कंटिन्यूज। She just returned back few days. I mean, I'm just trying to recollect. And you won't believe, she landed up in Ahmedabad in the morning, and 11:30, 12:30 or so, she was in my office. So that's the kind of attachment we have. So professionally तो है, और उसके अलावा भी we have family friends. हमारी family life भी अच्छी है. The best part of it, I was just trying to understand why this evolved. Probably we joined Bora. हमारे पास खोने को कुछ नहीं था। हम खाली सीख सकते थे। और probably जब आप एकदम bottom line पे चले जाते हो ना, तब आप निखर के आते हो। And I think so that's the thing which I have seen in her. हमारे ग्रुप को बहुत लोगों ने ज्वाइन किया था, but सर्वाइव बहुत कम कर पाए। यू नो लाइक इट्स लोहे को आप जितना गर्म करो, जितना मारो, वो तभी स्ट्रेंथ पकड़ता है। एंड प्रोबब्ली दैट इज व्हाट आई हैव सीन इन हर। पर्सनल तो है ही हम लोग का, सो मेनी 3 decades ऑफ हर जर्नी हियर, 3 decades ऑफ आवर जर्नी ऑल्सो। आई रिमेंबर वर्किंग विथ हर ऑल्सो। आई रिमेंबर आई हैड रिटन अ पेपर विथ हर ऑन फास्ट वेव एंड स्लो वेव करंट ड्राइव इन SST-1। हम फिजिक्स कोड साथ में चलाते थे, अकोमी था, LH19 एंड ऑल दोस थिंग्स। सो इट वाज लाइक बीटा पे हम साथ काम करते थे। एंड आई रिमेंबर वन मोर थिंग, बीटा मशीन वाज हाईली ऑक्युपाइड मशीन उस समय, और वो मशीन 12 महीने चलती थी, और उसमें भी मड्डू के 2 महीने, बोरा के 2 महीने, ब्ला ब्ला ब्ला, देयर सो मेनी पीपल। एंड हम 2 रिसर्च स्कॉलर थे जिसके पास मशीन 2 या 3 महीने के लिए आती थी। So she was so accommodative. हम लोगों ने डिसाइड किया कि ये 2 महीने को जो हम 4 महीने कैसे बनाएं। तो हमने बोला ठीक है, you do your work experiments in the morning and मैं आके रात को उसको चलाऊंगा। And मशीन को हम बंद भी नहीं करते थे। And that machine used to run for continuously 2-3 months. So that kind of rapport we had, understanding we had, and knowledge तो you saw from all these things. So I really appreciate, I find myself very fortunate to have a colleague, to have a friend like you. We spent good time, and while you were going through those slides, I was recollecting our 3 decades of togetherness. And I wish you all the best for your retired life. Stay healthy, stay active as you were here, and all the best for you in your second inning. Thank you.
Thank you, Pramod. So I'll request Aditya साहब say a few words. क्योंकि IPR में कोई ऐसा आदमी नहीं जिससे Aditya साहब से पाला नहीं पड़ा।
मेरे ख्याल से यहाँ पे अभी मैं सबसे पुराना आदमी मैं ही हूँ ITR का। तो जो मेरे गुरुजी थे डॉक्टर बोरा, उनके साथ मैंने भी ज्वाइन किया था, और मैं ये कह सकता हूँ कि IPR का जो कंट्रीब्यूशन है, उनका जो कंट्रीब्यूशन है IPR के लिए, वो कोई भूल नहीं सकता। क्योंकि उन्होंने इतने सारे पत्थर जो थे उनको हीरो बनाया तराश के। उसमें मैं पहला था। और मेरे को ना इतना तराशा कि 3-4 साल में मैं थक चुका था। तो मैं सोचा कि किसी तरह से मतलब मैं उनके नीचे से निकल जाऊं तो अच्छा है, बट जब तक मैं निकला तब तक मैं हीरा बन चुका था। उसके बाद बहुत सारे जेम, अपराजिता है, प्रमोद शर्मा है, शुक्ला जी हैं, राज सिंह है, सुनील है, आरएफ में जो भी लोग काम करते थे, क्योंकि पहले वो माइक्रोवेव में थे तो माइक्रोवेव से वो आरएफ में शिफ्ट हो गए, तो मैं बच गया था। उसके बाद मेरा थोड़ा फ्रीडम मिला मुझे, बट ये था उनका, उनको याद करके यही लगता है कि उन्होंने कुछ भी किया हो, कैसे भी किया हो, बट शायद वो बहुत अच्छा था हमारे सबके लिए जो भी उन्होंने किया, क्योंकि आईटीआर में इतने सारे डिफरेंट लोगों को डिफरेंट तरीके से मतलब उन्होंने सिखाया, जो भी सिखाया, और उसके बाद सब आज लीडर बने हुए हैं, अपने अपने फील्ड के जो हैं लीडर। अपराजिता के बारे में मैं इतना ही कहना चाहता हूँ कि बेसिकली the most dedicated lady in IPR for her work in IPR that I have seen in Aparajita. Because जैसे मुखर्जी ने बताया कि she came from a very small place and right up to that level that ITER में भी वर्क किया और इतना सारा IPR में डेवलपमेंट किया, तो it is a very big achievement basically for her also as well as IPR also. And first time जो है मतलब इतनी हाई पावर RF रेंज में इतनी हाई पावर सोर्स को डेवलप करना, उसको टेस्ट करना और पूरा ग्रुप खड़ा कर देना। बहुत सारे ग्रुप के लोग उसको याद रखेंगे कि इनका डेडिकेशन की वजह से ही ये सब कुछ हो पाया। ITER लैब में जो भी लैब इन्होंने डेवलप किया, सिस्टम डेवलप किए, तो हमेशा IPR याद करता रहेगा। और आई विश यू ऑल द बेस्ट फॉर योर न्यू जर्नी। एंड आप ऐसे ही हमेशा, जैसे आपके चेहरे पे खुशी मैंने देखी, स्माइल ही मैंने इनके चेहरे पे देखा है, तो आप हमेशा खुश रहो, स्वस्थ रहो, यही मेरी प्रभु से प्रार्थना है। और मुखर्जी रिटायरमेंट के बाद जरा ज्यादा ध्यान रखना। ओके, थैंक यू।
थैंक यू साहब। अभी मैं चंद्रमौली को रिक्वेस्ट करूँगा।
थैंक यू। अभी मैं अतरे जी ने जो कार्य किया उनसे बताता रिटायरमेंट। फर्स्ट पहला तो यह है कि उनका नाम अपराजिता है, तो कोई जीत नहीं सकता उनसे। शायद वो सबको हरा देते अपनी मुस्कुराहट से, ऐसा नहीं है कि वो फोर्सफुली जीतते हैं। So this is very good trait she has as such, or I would say it's a good property she has. One important point I wanted to make was both of us we worked in ITER together for 2 years, 2 years, and it was very nice to work with her there. And of course, before going there, here we had many interactions in the committees. And I always, as many people they say, she is always calm and provides the solutions. And never ever I have seen her scolding on anybody. This is my experience as such. I have not directly worked with her as such. Okay, but thank you very much for being with us in all this walks of life in professional life. And personally also we had many interactions and always we shared our experiences with each other. And this is really good to interact with her. जो रिटायरमेंट ऑफ इसके बाद में जो अपने उन्होंने हमको बताया क्या करने वाले हैं, शायद पता नहीं मुखर्जी को बताया कि नहीं, उन्होंने बताया क्या करने वाले हैं, तो शी सेड दैट शी विल गो टू हिमालयस। शी हैज डिक्लेयर्ड, आई डोंट नो, आई एम सॉरी आई एम डिक्लेयरिंग, बट शी सेड दैट। तो आप देख लीजिए क्या करना है। आपका क्या करना देख लीजिए, शी हैज डिसाइडेड ऑलरेडी। साल बताया, साल में बताया। But I know that someone who wants to go to Himalaya, they will go to Himalaya. And I wish her a good retirement life in Himalayas. Thank you very much.
मैं भी अच्छा आई
मेरा तो ऐसे कुछ ज्यादा इंटरेक्शन अपराजिता मैडम से नहीं है, लेकिन मैं अभी स्टिल आई वांट टू रिमेम्बर माय ओल्ड दिस थिंग, माय जॉइनिंग टू ITER organization, because that time in early 2007 May I joined ITER. So we were only three to join with after Dr. Bura. So in my mind it was a very great challenge for me, because I was feeling that I am the representative from IPR and I need to behave the way I need to give जो टेक्निकल और सब जो पार्टिसिपेशन है मीटिंग्स में, सो यहाँ हमको अपना डेकोरम और अपना वो बता के रखना पड़ेगा that among all the participating countries we are also equally in terms of practical knowledge, theoretical knowledge, everything. So मेरा पहला वेलकम ऑफिस के अंदर, मतलब जैसे ही वो मैं वहाँ उतरा, एक टैक्सी आई और मुझे लेकर वेलकम ऑफिस में गई. The moment I entered the welcome office, there was a huge picture on the wall, like this size, 20 feet by 10 feet, Audrey Duval and Aparajita madam. I saw, okay, madam is there, Indian, and welcoming a French lady is welcoming Indian. So that gave me a great sense of confidence. कि हाँ हमारा मतलब यहाँ पर उस तरीके का है और we can function well, operate well there with that great confidence. So that give me the boost there. So thank you for that. I will that picture with a Colgate smile. I still remember. And I wish you a happy second inning for your healthy and peaceful life. Thank you.
अभी मैं रंजना मैडम को रिक्वेस्ट करूंगा, बहुत देर से बोल रही, पर आज से आखिरी चैलेंज नहीं दिया तो फिर मैं बाहर निकल के बताऊंगा.
चल रहा है ना, आवाज आ रही है ना. मेरा मैं ऐसे सब नहीं बोलूंगी, खुश रहो, खुश रहने ही वाली है तो बोलने का मेरा एसोसिएशन 93 से हुआ अपराजिता से. पहले मैं जानती नहीं थी इतना, कोई एक कोने के वहाँ हॉस्टल था हमारा नवरंगपुरा में, तो वहाँ एक क्वार्टर्स थे, वो वहाँ रहती थी, तो मुझे ज्यादा पता नहीं था. उसके बाद जब 95 में हम लोग ने मैं सक्सेना साहब के ग्रुप में ज्वाइन किया था और जबरदस्त डांट पड़ती थी, तो एक दिन बड़े मायूस हो गई मैं कि मतलब डांट तो ऐसी पड़ी कि कुछ पूछो नहीं. तो मैं बड़े उदास होके आंसू आंसू आ गए आंखों में और बड़ा दिल बैठ गया. तो अपराजिता आई, बोले क्या हुआ, तो मैं बताया उसे कहानी कि ऐसा ऐसा हुआ, तो ये कुछ गलत हो गया लिखने में, तो डांट पड़ गई. तो बोली सक्सेना साहब के डांट से डरती हो? हाँ मैं देखो हमको बोला तो तुम्हें एक दिन पड़ी है, हम तो रोज इससे गुजरते हैं. तो एनीवे उस दिन उसने काफी सांत्वना भी दी. तो फिर तो ऐसा हुआ, ऐसी इन्होंने मुझे पट्टी पढ़ाई कि उसके बाद सक्सेना साहब ने, शायद हम लोग कैंटीन में बैठे थे और मस्ती कर रहे थे, बहुत हंस बोल रहे थे, और उससे सुबह ही मुझे डांट पड़ी थी सक्सेना साहब से. तो बोलते ये दो लेडीज, इनको मिला दो तो पूरा IPR में कितना भी डांटा इनको कोई फर्क ही नहीं पड़ता. ये स्टेटमेंट वो कैंटीन में दे रहे थे. तो उसके बाद ऐसा हुआ, मतलब ऐसे कई इंसिडेंट्स हुए, और वो एक ही एग्जांपल देती थी कि देखो हमारा तो एनिलिंग वगैरह सब बोला के अंदर हुआ, तो तुम कभी भी ऐसे दुखी नहीं होना. तो ये जो सीखा मैंने उससे कि होता रहता है इसमें कि कभी ऊपर वाले कुछ कुछ बोल देते हैं, तो कपड़ा झाड़ के आ जाना, उसको लेके नहीं आना साथ में. फिर हम कभी बहुत ऐसे इमेजिनेटिव गप्पे लगाते थे, बहुत इमेजिनेशन रहता था उसमें। तो बोले यार अब तो यार कुछ साल बाद ऐसा मौका आएगा कि हम रिटायर हो जाएंगे, तो जो दिन आज हम आ ही गया, तो उसके बाद थोड़े साल बाद हम ऊपर चले जाएंगे। तो बोले यार ऊपर जाके करेंगे क्या? तो मैंने कहा यार भगवान ने इतने सारे फ्यूजन रिएक्टर बनाए, उसमें कहीं काम में लगा देंगे ईश्वर। तो बोले तो करने को क्या बोलेंगे, सब वर्किंग ऑर्डर में है ऊपर। तो मैंने बोला क्या पता एनुअल मेंटेनेंस कॉन्ट्रैक्ट में लगा दे। तो हम इसी तरह गप्पे लगा रहे थे, तो बोले यार, मैंने बोला यार वहां तो अपन यहाँ तो एक चीक मारते हैं तो उनका एनुअल कॉन्ट्रैक्ट हो जाता है, तो ऐसे अपने को कैसे देंगे एनुअल मेंटेनेंस कॉन्ट्रैक्ट? फिर हम विचार किया, हमने लाइट ईयर कॉन्ट्रैक्ट देंगे हमको, एक लाइट ईयर का कॉन्ट्रैक्ट लीजिए और हमारे स्टार्स मेंटेन कीजिए। तो इस तरह की कई इमेजिनेटिव बातें हम लोग करते रहते थे और काफी अच्छा समय बीता। जो हर मुसीबत में हंसते मुस्कुराते रहना मैंने अपराजिता से ही सीखा, और वो मैं अभी तक कर रही हूँ, उसके नक्शे कदम पे चल रही हूँ। तो बहुत अच्छा समय, एक फ्रेंड बोलो, एक कुलीग बोलो, एक साथ में तो हमने कभी काम नहीं किया, लेकिन फिर भी काफी साथ रहे। तो थैंक यू अपराजिता, बहुत मस्ती की हमारे साथ, और ऐसे भी हम बाद में भी मिलते रहेंगे और जो तुमने सिखाया है वो फॉलो करते रहेंगे। थैंक यू।
Thank you, Anjana. So we are going towards the end. I think I should invite शुक्ला जी, because हमारा जो बोरा साहब के शिष्य हैं, उनका यंगेस्ट। एक्चुअली क्या है कि बोरा साहब डांटते बहुत थे, नहीं बोल रहा, लेकिन कहते हैं जो अपने सीनियर्स होते हैं उनका एक्सपीरियंस हमें यूज करना चाहिए। एक बार मुझे याद है, लोग एसएसटी में काम कर रहे थे, तो हमने पिलर के साथ में टेबल लगा रखी थी, वहीं पर अपना वो प्रेशर चेक कर रहे थे, इसका दाखिल लाइन है कि वो उसका वेल्डिंग वगैरह प्रॉपर हुआ कि नहीं हुआ। ऐसा है थोड़ा सी टेबल के ध्यान रखता हूँ, तो हम जैसे थे मतलब हमारे थोड़ा सा तो कुछ भी चलता था, दूसरे वो गुस्से थे, हम मुझे ज़्यादा डबल गुस्से होते थे। मुझे सर ये तो नहीं गई, मेरा असली को पता नहीं था कि ये आपका काम नहीं है, क्योंकि सब सीखना आप अपना काम नहीं, यहाँ तक का वहाँ बात हो गई। ठीक है, मैं तुमको देख रहा हूँ, गुस्सा को चले गए। तो फिर आधे घंटे बाद बुलाया, तो मतलब बोल रहा हूँ उसको वहाँ जाना है। मैंने कहा साथ में बोले हटा देते उसको, आप यकीन मानिए अगले ही दिन मैं और दानी वहाँ पे टेस्ट कर रहे थे, पेन को टेस्ट कर रहे थे उसका वेल्डिंग, पैसा ले गया हमने पूरा पेन ठक से तो पूरे ऊपर जाओ, ऊपर से नीचे आओ। सही में अगर हमारा टेबल होता वहाँ बैठते थे तो सिर का हमारा हो गया। तो एक्सप्रेस लोगों का एक जो एक्सप्रेस होता है वो कहीं ना कहीं जरूर काम आता है। तो जब मैं बोला साहब से काम
बिल्कुल अब राइट साइड से ठीक है। ये आयत ग्रुप जो है वो देखा जाए तो एक परिवार ही रहा है पूरा। ICRH LSCD करते रहे, लेकिन हम लोग साथ रहे, कभी भी मतलब ऐसा नहीं रहा। और हमेशा देखा जाए तो अपराजिता से हमने बहुत सीखा है, चाहे कहीं हो मतलब कुछ भी कोई भी इशू रहता था या कुछ भी, जैसे जो ठीक है भाई अपराजिता से बात कर लो और ठीक है मतलब यू विल सेटल द थिंग। सेम वे ऐसे रहा है। और ऐसे हम लोग अभी यही एक बात कर रहे थे, अभी मिले एक टाइम पे कि हम भाई उस टाइम पे कभी कभी थोड़ा बहुत कुछ गाड़ी चलाते थे, एक उसको लेके गए, कुछ ऐसा काम था, तो मैं अपनी गाड़ी चला के जब लगाया, जब उसको पार्किंग किया तो बोला कि नहीं पार्किंग करके लगाया, बोला हाँ अब हमने तुमको सर्टिफिकेट दे दिया है, आप अच्छा ड्राइव करते हो। मतलब इस तरीके की चीजें नहीं है। और वैसे भी रहा है मतलब देखा जाए तो कि काफी हद तक एसोसिएशन रहा है, मतलब कभी भी ये नहीं लगा है कि ये ICRH है, ICRH LSCD है, ऐसा कुछ भी नहीं है। हम लोग एक साथ ही काम किए हैं। ITER में जाने के बाद थोड़ा वो हुआ, लेकिन उसके बावजूद भी हम लोग शायद कभी कभी मीटर से भी कुछ जब भी हीटिंग के ऊपर कुछ बात हुई तो भी हम लोगों ने कम्युनिकेट किया है। तो अपराजिता के बारे में सिर्फ इतना ही कहना है कि नो डाउट शी इज वन ऑफ द बेस्ट साइंटिस्ट एंड बेस्ट मैनेजर फॉर द अपने जो पूरे उसको लेके चले हैं, अपने ग्रुप को लेके चले हैं। और कोई भी चीज मतलब जो है आज रिटायरमेंट का दिन, उसको रिटायरमेंट नहीं बोलते, इट इज सम बिगनिंग। और जो कुछ आपने पीछे अचीव किया उसके लिए बधाई, आगे अचीव करोगे उसके लिए बधाई। धन्यवाद।
सो अगर कोई रह गया हो मेरे नजर से, किसी को कुछ बोलना हो तो नाम बोलो। है राजेश सर? हाँ यार आगे मिले, सॉरी बेटा।
So, my association with Aparajita is not professional, it is only personal. But I would like to mention two things I admire her. One for her pleasant smile, and the other for her simplicity and humbleness. So these three qualities of yours is a great inspiration for us as ladies. And the other thing that I admire in you is your leadership quality. So I hope all the women who are here will appreciate. You are a source of inspiration for us, and we pray to the Almighty to give you good health and wish you a life full of laughter, joy, and happiness. Thank you.
Rajneesh, Lakshmi, hi.
Actually, I was not directly working under Aparajita, but I think right from beginning, 96, when we joined and room number 31, and that's where we used to sit together, and she was just besides me. And I think from there onwards, for several years, even in the ITER project also, several occasions, we were always together, because I was also one of the junior most project manager and she was my senior, and we were probably pitted against NB Matusa, and who used to be little in a differential treatment, whosoever comes from RF group, and we used to have a different kind of a treatment. Like every time there was something, Aparajita, Lakshmikant, please come to my office. And there used to be large number of questions. And Varva is sitting on the other side, I still remember. And the requirement was on the power supply. And he used to ask Aparajita, where is your power supply? When it is coming? And Varva is keeping quiet there. So those kind of, there was a lot of pressure, I guess, at that time. And we were and I remember there were during Borasat time, I think we used to make a lot of presentations, and then conferences. We used to have a good discussion with Pramod and Aparajita, because these are the ones who we could approach. And anything going to Professor Bora, everybody knows. One fine day when I joined newly, I thought there was some doubt. I thought he is a great professor, so he will answer my question. I went to him and he said, I am not understanding this. He showed at me left and right. What for you there? It is your job to do this. And I should ask the questions, you should answer me. So that our approach. So for us, Pramod and Aparajita, these people were there. And I have a lot of memories. Like I remember there was this one room where JP Singh and Aparajita Madam both were tightening large number of nut bolts and SS. I think that was antenna interface facility or something. So that time I was new, and she's being a lady, but she never hesitated in any of this physical work. So that is something which I always feel. And then other thing, many people touch. She is very calm. And by nature, I used to be a little anxious. So then sometimes it gives me kind of a motivation that one should remain calm and silent. And I think there are many other things which I noticed was she's I think a very determined person, you know, because many times we discuss if something is being decided, she never wants to retreat back or take back or go back in by their decisions. I think this one quality which I observed, which is probably has taken us to kind of the place where she has achieved and the kind of achievement she has made. Madam, there are many other memories, but I would like to wish you all the best for all your endeavors, and thank you very much for being with us and guiding us at times. Thank you.
Rajneesh, your turn.
हेलो मैडम। हमें याद आ रही है कि जब हम 99 में IPR ज्वाइन किया था एज ए इंजीनियर SC, तो सबसे पहले मेरा लड़का हुआ था और मैं मिठाई लेके उसी दिन मैडम भी मैटरनिटी लीव के बाद ज्वाइन की थी। क्लाइस्टोन का टेस्टिंग नहीं, उससे पहले हम दोनों एक दूसरे को देखे भी नहीं थे। क्लाइस्टोन की टेस्टिंग हो रही थी और हम दोनों एक दूसरे को मिठाई खिला रहे थे। वो फर्स्ट इंटरेक्शन हमारा था। और उसके बाद हमने AMN सिस्टम ऑटोमेटिक मैचिंग नेटवर्क पे काम शुरू किया। संपा हमारे साथ थी। उसके बाद संपा के जाने के बाद इन्होंने ही हमें सिखाया कि उसमें क्या करना है, कैसे करना है, क्योंकि हमें फिजिक्स आती नहीं थी। हमने तो डाटा एक्विजिशन कंट्रोल सिस्टम से काम शुरू किया था। फिर एंटीना डिजाइन, एंटीना इम्पीडेंस क्या होता है, कैसे मैचिंग होती है, ये सब मैडम के साथ काम करके हमने सीखा है। और 99 से लेके आज तक हम लोग साथ में काम किया। बहुत सारे डिस्कशन भी होते थे। डिस्कशन में बहुत कुछ कभी कभी और डिस्कशन भी होती थी, लेकिन हमेशा हम लोगों ने कुछ सीखा ही एक दूसरे से डिस्कस करके, और बहुत ही अच्छा हमारा अनुभव रहा है। फ्यूचर के लिए बेस्ट ऑफ लक और थैंक यू।
So I think MP को बोलना चाहिए। आजा
बहुत टाइम बात करते हैं। नेक्स्ट वाला
MP का क्वेश्चन है कि फेयरवेल बोनस हमको दी जा रही है या पैसा दी जा रही है? जिसने बोनस आपके साथ काम किया है ना, वो उनको भूल नहीं सकता है। हम लोगों को ज्यादा सर आप लोगों को पता नहीं है, जिन्होंने सर काम नहीं किया उनको नहीं पता है, हमें पता है क्या चीज से बोला था। तो इफ एनीबॉडी एल्स वांट्स टू टू रिलेट क्वालिटी जो है वो देखिए बोल रहा था।
बोनस आपको दे दिया, वो लाइफ में किसी मुश्किल का सामना कर सकता है। तो एनीवे फैमिली फ्रेंड्स हैं एंड हम लोग बहुत सारे ओकेजन पे साथ में फंक्शन करे बच्चों के। एंड आई ऑब्जर्व कभी बहुत मुश्किल में भी सीखी काम। पेरेंट्स, उनके पेरेंट्स साथ में थे। एक बार थोड़ी बीमार पड़े तो शी वाज अलोन, नोबडी वाज आउटसाइड, ही वाज इन जेर्मनी। तो अकेले हैंडल करना विदाउट एनी कोलैबोरेशन, वो सब काफी अच्छी क्वालिटीज है। सो दैट्स व्हाट आई ऑब्जर्व एंड आई विश यू ऑल द बेस्ट इन योर लाइफ। सेकेंडली वो बोलते हैं एक्चुअली हमारा एक अलग स्पिरिचुअल लाइफ की हम लोग को अपॉर्चुनिटी मिल जाए। गुड लक।
एक चीज मुझे बहुत भी याद आ रही है, मैं बात में आई कि हम पैसा को हमने इतना अप्रिशिएट किया है मुखर्जी साहब को उससे मैच ही करना पड़ेगा मेरे साथ। Anybody else? Just from the so
आप दोनों के साथ में है तो एक दूसरे का साथ
हैं
आप दोनों का एक ही महीने में साथ में है तो आप
हमारे साथ में
उस समय एग्री कौन करेगा इतना अच्छा वो दिखा होगा।
मैं कर लूंगा अपने में। पर मैं अपराजिता में जो ऑफर देने वाला था जब मैं मिलते आरएस में इंडस्ट्री चलाएंगे ITER इंडिया को बहुत जरूरत पड़ेगी आरएस कंट्री हम लोग सोचेंगे उस बारे में हम लोग so thanks you all that you all came and I'm thankful to Aparajita and thankful to Mukherjee sir that you all came and made this perfect.
First of all, I would like to thank everyone for giving this kind of appreciation, and then, I mean, I never considered that I am actually, having so many qualities. अच्छा हुआ आज मैं आज रिटायरमेंट इसलिए मुझे पता चला कि कितना क्वालिटीज है। पता नहीं आप लोग एक्स्ट्रा बोल रहे हो ना क्या, मतलब exaggeration or not, it's really the fact. But I think that I have tried my best to basically be very perfect and try to build this team, to be compatible with the ITER requirements especially. Of course, I worked for SST-1 as well as for Aditya with all of you, and then I had learned many things from all of you. So in fact, you are all my teachers, and I try to learn from everyone and try to actually keep myself always active and always alert. And I also value the others basically what to call that mindset and everything. People are there talking about Borasar, but one thing I can say that he was very supportive basically when we are actually challenged by other teams, especially in different say forum. And then sometimes criticism from other section. So that time he was very supportive, and I've seen actually in some of our this promotion reviews, he was supported by like anything. So maybe he was trying to basically shape our career, but at the end he was very supportive. And I had some kind of personal interaction with him also. He always act like guardian. Sometimes we had a lot of discussion, lot of dispute, lot of arguments, but finally supported in many ways. So एक्चुअली आप लोगों को शायद पता होगा कि एक टाइम था जब हमारा आरएफ ग्रुप को लोग बोलते थे रोते फिरते को, रोते फिरते आरएफ रोते फिरते बेसिकली हम लोग पूरा टाइम ही रोते थे ना, क्योंकि ये ठीक नहीं है, वो ठीक नहीं है, आज इसने डाटा कल उसने डाटा, इस टाइप का। तो बेसिकली जेपी सिंह के साथ मैंने बहुत काम किया था। इनफैक्ट सारे वैक्यूम सिस्टम का नॉलेज जो है ना, मुझे जेपी सिंह से ही मिला था। ही वाज वेरी परफेक्ट, बट ऑलवेज ही वाज एक्चुअली वर्किंग बिहाइंड द सीन। सो उनका नेचर बहुत अच्छा था, और उन्होंने मतलब जब भी बोरा सर डांटते थे तो वो रो देते थे। तो एक बार एक ऐसी इंसिडेंट हुआ था जब हम लोग आदित्य में काम कर रहे थे, इंटरफेस लगा रहे थे एक्चुअली। तो सडनली बोरा सर आए, और एक्चुअली वो टाइम हो गया था एक्चुअली, मे बी बाई 6 o'clock हम लोग को कंप्लीट करना था, लेकिन तब तक फ्लैंच भी बंद नहीं हुआ। तो उन्होंने आके बहुत डांटा, तो डांट के देखो निकल गया। तो ये तो रोज रोना चालू कर दिया जेपी, तो बाकी लोग भी इकट्ठा हो जाते थे। एक्चुअली विद इन 1 मीटर ना सब पूरा साथ में हो जाते थे जब भी डांटते थे, बाकी लोग देखने के लिए आ जाते थे। उनको मजा आता था एक्चुअली, मतलब हम दोनों को डांट रहे देख के, तो सब 1 मीटर का अंदर एकदम पास में है। तो डांटने के बाद निकल दिया बोरा सर। तो इसके बाद जेपी सिंह ने रोना चालू कर दिया। मैं उसको बोल रही कुछ नहीं होता है, ऐसे छोड़ो हम लोग कर लेंगे। तो बाकी लोग मुझे कुछ पूछा था, मुझे एग्जैक्टली याद नहीं, इसने पूछा कि मैडम ये रो रहा है तो आपको कुछ नहीं हुआ। तो एक्चुअली मुझे लगता है कि उनका जो भी ट्रीटमेंट था, जो भी था ना, उससे हम लोगों ने बहुत कुछ सीखा भी। ऐसे नहीं कि सिर्फ डांटते थे। तो मुझे लगता है कि बोथ साइड था, पॉजिटिव एज वेल एज नेगेटिव, दोनों साइड था। एंड आई थिंक दैट मे बी आज मैं जो भी पोजीशन से रिटायर हो रही हूँ, तो उसके पीछे बाकी मतलब प्रोफेसर काव, देन सेन साहब, देन शिशिर, मे बी मट्टू ऑल्सो, प्रोफेसर मट्टू ऑल्सो, वो लोग थे। लेकिन बोरा सर का भी कंट्रीब्यूशन कुछ कम नहीं है। And also, of course, all contribution from our group, especially from RF group. And I learned many things from everyone. So thank you for your all support and kind help throughout my entire journey. Thank you all.
Thank you, Aparajita.
ऐसे ही होता है, सब लोग आते हैं, कुछ जने नीचे बैठ जाते हैं।
यहाँ बैठ जाओ ना।
आना चाहिए था।
रंजीत साहब कुछ बोलना चाह रहे हैं?
जदीद
रह गया।
वो बोलना था मेरे को ऐसे ही
विजय का दूसरा वाला में बोला साहब लोगों कोई बात नहीं
कैमरा निकालना नीचे।
हाँ सही बता आप